Well, hello everyone and welcome to another episode of Shenanigans with Audrey. I'm your girl Audrey with ACCUPLACER Tutoring. We are in for a little expansion for College Algebra. And it looks like a lot of people that are currently in College Algebra right now are kind of looking at domain of functions. So that's what we're going to focus on for today. We're going to take a look at how do you find your domain? How do you find those restraints? And also to put it in interval notation, okay? So if you haven't talked about interval notation, and maybe haven't seen interval notation early on in the semester, or maybe even for the last semester, this is going to be a little tricky. But I did do a live on the interval notation before, but I'm going to review a lot of that as we progress on. So as you guys come in, go ahead and tap away. We're going to try to get through this without any kind of craziness going on. All right. So normally, if you don't do any kind of modifications or any kind of altering of the function, linear, quadratic, cubic, quartic, most of them, your domain is always going to be all real numbers. That's what the double R stands for, all real numbers. But if they start modifying it, they start making it into a radical, they start making it into a ratio, they start putting the radicand underneath, they start doing any kind of twist and turn, you're basically trying to do is not have your denominator equal 0. So what is it? What is that number? What is that expression? What is that phrase that is going to make your denominator equal to 0? Okay, so that's what we're looking at. So let's take a look at a couple examples. All right. Oh, yesterday was terrible, but we'll move on from that. Okay, so right now there's 275 of us here, and I'm only seeing 2 taps. We want to get as many people into the live as much as possible, so we're going to get started when we're at 1K. So we're going to need to do a massive overhaul with the taps so we can keep things going. This is a free live. The only thing I'm asking you to do right now is just to tap your screen. That's it. Trust me, you don't get a big prize. All it is just helping the live so more people can come in. So those that are taking College Algebra, this is going to be the live for you. For those that are taking your ASVAB, your ACCUPLACER, this is definitely going to be the live for you. GED, you can come on in if you want, but this is not really going to be your live. But why not see the other side of the coin, right? So as you guys are coming in, go ahead and mad tap. That's okay. I should be used to it by now. Ever since I was 14, my birthdays was nothing but garbage. So nothing new. So if anything, go ahead and just tap away so we can get started at our 1K. Okay, we're almost there. All right, there we are. So for our first function, we have our f of x is equal to 2x minus 3. So what we're doing for our domain is we want to know what value of x is going to give us a restriction for this function. So if you recall, this is my slope, which is positive. This is my y-intercept, which is negative. So it's basically telling me, if I may do a quick little sketch, this is basically telling me that my graph, again, linear, because my highest exponent is a 1. If you don't see anything, it's assumed to be a 1. So we got a straight line. So if you notice, from going to positive infinity and going to negative infinity, I can pick any x value what I want, and it will give me an exactly one y value. So with that, this does not give me any kind of restraint. So this is why I said here, if it's a linear function, okay, no flipping anything around, not putting it, making it into a fraction or anything like that, it will give me all real numbers. Now, how you can represent all real numbers as an interval notation. That means I'm going from negative infinity all the way up to positive infinity. And then infinity doesn't have an end. So it's called unbounded because it really doesn't have a stopping point. So when it's unbounded, when it's not really stopping at a certain area, you're going to use parentheses. Okay? So this is representing my double R, which means all real numbers. That's your answer to that first one. You're like, what? That's it? I'm like, yep, that's it. So let's say g of x equals 3x cubed. I'm going to move this over in a second. 5x squared plus 3x minus 5. Okay. So we have 3x cubed minus 5x squared plus 3x minus 5. Okay. How about? So, going to my highest degree. My highest degree, aka the highest exponent, is to the third power. So this is a cubic function. So let me just see if I can do a quick sketch of a cubic function. So cubic functions, it's almost like they do almost like an S type thing. Okay. So we're just seeing a small snapshot. So I'm saying that I'm looking at my values of x. At any point of value of x, I will have a y. Because this adventure is going to keep going up and out, up and out, up and out. Okay? Just as much as this is going to go down and out, down and out, down and out. So our domain, there isn't any restriction. Okay, so our domain, again, is going to be all real numbers. And the reason why I picked this equation or this function is just to see that, hey, linear-wise, all real numbers, that's what it looks like. Cubic-wise, this is what it looks like, is all real numbers. Okay. All right. So let's try this one. Okay. Now for this one, this is a square root. So a square root usually has one particular spot, and then it either increases in one direction or one particular spot, and it also increases or decreases in another direction. So okay. All right. So now what we're doing, because remember, square roots are a little funny, especially if what's underneath the square root, which if your radicand is a negative number. Because if you have a negative number underneath a square root, or an even root, I shall say, you're always going to have, well, especially square roots, you're going to have what's called complex numbers, okay, or imaginary numbers. That's what they use that letter I for, So if you ever see anything, you notice that in general math, you never see I used as a variable. I is actually a number. Okay, same thing with E. Okay, E and I are actual numbers. So when it comes down to it, the key thing about the domain is we want something that's going to give me a positive number underneath this square root, as well as 0. So in order for us to figure it out, we use 0 as like the commonplace. So what I'm going to do is I'm going to take the radicand, that 4 minus x, and I'm going to have it equal 0. Because I want to know what is a number that's going to make that particular equation equal to 0 or function equal to 0. Okay, that's all right. Just follow along, guys. Just follow along. Okay, because if not, if you haven't had it yet, it's coming if you're currently in college algebra. So here, we want to solve this equation for x. So this part, everybody should be able to kind of do. So if I want to get x by itself, that means I need to move this 4. So it's a positive 4 because the signage is always to the left. This negative sign is with this x. So that means this is a positive 4. I want to do the opposite, so I'm going to subtract 4 on both sides. So negative 4 minus 4 will give me 0, but I don't need that 0 as a placeholder because I still have this negative x over here. So now we have negative x equals negative 4. All right. So now I don't want to know what negative x equals. I want to know what x equals. So that means I need to divide both sides by negative 1. So negative divided by negative, that will give me a positive. And negative 4 divided by negative 1, that will give me 4. Okay, so now I know if I plug a 4 in for the x, 4 minus 4, that will give me 0. The square root of 0 is 0. But knowing that 0 is going to be, all right, my staple where I normally start. If I go below 4, will I get a positive number? So if I go below 4, I'm going to get a 3. 4 minus 3, that gives me 1. The square root of 1 is 1. So that works. We don't have a negative. So if I do a 2, I got 4 minus 2. 4 minus 2 will give me 2. And then I have the square root of 2. And square root of 2 is still positive. Okay, it's not going to give me a nice even number because it's irrational, but it's still positive. But if I plug, let me go the other end. If I plug the 5 in for the x, I got 4 minus 5. That gives me a negative 1. And negative 1, that's giving me those imaginary numbers, those things with i's, the square root of negative 1. We don't want that. We want real numbers, not complex, real numbers. So that means since when I was going down, so even if I put 0, I got the square root of 4. Square root of 4 gives me 2. That's a positive number. That's awesome. So it looks like the pattern is, if I may write it out as an inequality, is that x is all that will make it into a true statement. It has to be less than or equal to 4. Okay. Because I used 3 and it gave me a positive answer. I used 2, it gave me a positive answer. I used 0, it gave me a positive answer. If I plug in, let's say, a what will be nice and easy? A negative 5. If I plugged in a -5 for the x, remember, I'm going to minus a negative. When I minus a negative, it turns positive, right? Exactly. All negative numbers will work as well. Exactly. Because a minus a -5 will turn into a +5. So 4 plus 5, that gives me 9. The square root of 9 is 3. That's a positive answer, and it works. So I can use from 4 all the way to what? All the way to what? Behave, I used 3. That was the first thing I did. Okay, there it is. All the way to -infinity. Yes. So I want to go all the way to -infinity. So if I want to make this into an interval notation, I always put the lowest number first. So my lowest number is going to be -infinity all the way to 4. Okay? So infinities always get a parenthesis. Now the 4, it can equal to 4. It can include 4. Because when I plug the 4 in for the x, I got 0. And the square root of 0 is 0. And that's perfectly fine. Okay? It's not giving me an imaginary number. So that means I'm including 4. When you include it, that means you're giving it a bracket. There we go. Yeah, when you're in middle school, you're not going to know this. That's why this is for college algebra, as it said in the beginning. Okay. All right. Okay. So let's try another one. Okay, so that's going to be, and I can use any number from -infinity up to 4 to give me a true statement of our original. All right. So now, let's try this one. G of x is equal to 4 over 1 minus x. Okay, so g of x is equal to 4 over 1 minus x. Okay, no problem, Jimson. Yes, because PSATs, well, especially for the 11th grade, the PSATs goes all the way up and includes Algebra 2. So PSATs and SAT, unless it's one of those 9th grade things. You should learn this in high school. Yep, but a lot of people had this in college algebra. All right. Now, when you see it as a fraction, your main focus for your denominator, for your x's, is going to be the denominator. The domain denominator, DD. Okay? So, especially for the stage that you guys are going to be on. So you want to know what's going to make this denominator equal 0. And the reason why you want to know, because anytime you take a number divided by 0, that's going to be an undefined. That's not going to give you 0. It's going to be 0 when it's 0 divided by a number. If the 0 is in the numerator, your answer is 0. If your 0 is in the denominator, that's going to be an undefined function. Okay? So we want to know what is going to make this denominator equal to 0. So let's set it equal to 0 to find out. So if I want to solve for x, I'm going to subtract the 1 on both sides. So you got 1 minus 1. Then what comes down is my negative x is equal to 0 minus 1 gives me a negative 1. But I don't want to know what negative x is. I want to know what x is. So I'm dividing both sides by negative 1. So that's how I got my x equals, and a negative divided by a negative is a positive. 1 divided by 1 is 1. So now, if I look at it, I want to see which way should I go on the number line. Should I go towards positive infinity, or should I go towards negative infinity that's going to continue to give me stuff, give me any kind of trouble? But since it's a fraction, that's division. So when it's a fraction, you don't really have to go either side. Because if I put a negative here, and this is like a linear function down here in the denominator, I'm going to be perfectly fine. If I put like a negative 5 here, it's like 1 minus negative 5 minus a negative gives me a positive, and 1 plus 5 gives me 6. Hey, that's fine to have a 6 in the denominator. Then I can go and reduce it. All right, no big whoop. If I wanted to put a 28 down here, 1 minus 28, that'll give me a negative 27. 4 over negative 27, all right, that's not bad. But the only thing that would give us trouble is when this equals 0. So that means my domain can be any number except for 1. 1 is the only number in this situation that will make that denominator equal to 0. So I'm looking at everything except for 1. So that means I'm going to look, excuse me. I know, it just all of a sudden just came on me. Okay, so that means I can tackle everything from negative infinity to 1. Okay, don't include it, so that's why it's a parenthesis. And then I can also go for the other end of the spectrum, which is 1 and positive infinity. So this is basically saying, in this interval notation, it could be any number except for 1. Okay? Okay, not today. Nope. All right. All right, so let's try this one. And we'll keep an f of x. It's negative 3 over 4 plus x squared. Okay, so here's another fraction. Notice we have a degree of 2 in the denominator. This doesn't mean that you're going to get a quadratic. Okay, it's not in its standard form, it's not in its vertex form, and it's not in its intercept form. But we want to know what value of x is going to make the denominator equal to 0, because that is when it's going to be undefined. So in order for us to do this, we're going to take our expression. So we got our 4 plus x squared, and we're going to set it equal to 0. Okay. All right. So the brackets include the parentheses. The brackets are bounded, and the parenthesis is unbounded. So we want to solve this equation for x. So that means we're going to subtract 4 on both sides. Okay, so 4 minus 4 will give us a 0, but we don't need the 0 because we still have this x squared in its spot. So when we put in, we're going to have our 0 minus 4, so that gives me negative 4. But then we do our square root. So this, remember, square and square roots cancel out, but then this gives me a negative under a square root. Huh. So it's not negative 2. Okay? Can't have negatives under square roots, because that gives us, yes, Z-pond. There you go. Those imaginary numbers. Yes, John. But we don't care about the imaginary numbers. We want to know what real numbers, okay, not the imaginary, not the complex. We want to know what real numbers that we're going to put in here that's going to give me a 0. If you put in negative 8, Mr. L, negative 8 times negative 8, we got a negative times a negative. That gives me a positive. So that'll give me a positive 64. So we'll still get an answer here. Okay. So nothing is going to give us a 0. Even because if I put a negative in here, it's going to turn positive because of the square. If I put a positive in here, guess what? It's going to still stay positive. So there isn't a restriction. Okay? There isn't a restriction for real numbers. So that means our answer is going to be from negative infinity to positive infinity. Because once I saw I'm going to get plus minus 2i. Okay. Once I'm going to get what's called a complex number, okay? Anytime you see a negative underneath an even root, this is a square root. Every time you see a negative, you're going to get a complex number. And complex numbers, they always come in pairs. So, but we don't care about imaginary numbers. Then you go back and just say, all right, well, I know if I had an imaginary number, it will make it equal 0. But are there any real numbers, counting numbers, whole numbers, integers, that will make this equal to 0? And the answer to that is no. So that means I can plug in any number I want for x, and I will get a regular number. Okay, I will get a solution. Okay. All right. Okay. Let's try another one. Let's step it up a notch. Okay, this is College Algebra. It's in the title of the live. Whew. Okay. All right. Yes, Z-pon bracket stop to that number and parentheses keep going. Yep, one bounded is bracket, unbounded is parenthesis. Okay. All right. Okay. So this time, okay, we're not really solving, but we're simplifying. So first off, again, focusing our attention on the denominator. Okay, so what do we have in common? Do we have a GCF? I'm going to put that in blue. What's my GCF? Okay. So we're looking just at the denominator. Okay. So we got our x's. We got our x's. Okay. It's not a perfect square. The reason why? It's a plus. Okay. It's a plus. If it was a minus, you can do the difference of squares. There's no such thing as a sum of squares. Okay. But you're thinking, which I like that. Who is that? Allie? You're thinking, which is good. Okay, so since we're focusing on the domain, so you guys notice that they all have an x in common. So what will remain, since there's two x's out here, we pulled one x out, there's one x that stays inside. Then we have a positive being divided by a positive, give me positive. So we have 4x divided by x will leave us a remainder of 4. Okay, so this in blue is this factored. So but then I'm going to take a look, see if I can cancel anything out, which I can't because 2x minus 1 completely different from x plus 4. So now we're dealing with these two lovely factors. And again, just like we've been doing before, we want to know when the denominator is going to equal to 0. So since it's already factored, we just need to set these two in for or equal to 0. So that means you have one that's going to be x is equal to 0, and the other equation is going to be x plus 4 is equal to 0. Well, this one's already solved. That's one of them. So 0 is one of the things that can make this denominator equal to 0, and we don't want that, right? So now, what else can make it equal to 0? If I subtract my 4, I get x is equal to negative 4. So that means if I took this negative 4 and I go back to my original, negative 4 squared will give me 16, and 4 times negative 4 will give me negative 16. 16 minus 16 will give me 0. So this time I have two solutions that will make this denominator 0. Okay. So how do I represent that? I think of my lowest number, okay? Not to insult your intelligence, but my lowest number of these two is a negative 4. So if I think of the number line, it almost looks like this if I did it as an inequality. As an inequality would look like negative 4, Okay, less than or equal to x, which is less than or equal to 0. Really not equal to, but you know what I'm saying. Okay. So we're saying from negative infinity up to negative 4. Okay. But we have to mention this 0. But in order for me to do that, I need to mention what's happening between negative 4 and 0. And we use this symbol right here to represent union. So we're looking at negative 4. And anytime we're going in between numbers like this, we always use parentheses. There is nothing definite with any of this. Okay? Because we're saying that, hey, you can use all the numbers that are less than negative 4, skip number negative 4. Then, yeah, you can use the numbers from negative 4 to 0, but skip 0. And then you can go from 0 to positive infinity. This is what your answer is going to look like. So by doing these things, you're saying, all right, less than negative 4, but skip negative 4. In between negative 4 and 0, okay, but don't use 0. And then from 0 to positive infinity. That's how you will write it as an interval notation. Okay. Okay. So the discriminant will tell you like what type and how many solutions you will have. But we don't need to do that. We just need to know what is going to give us 0. So we're looking at the domain and the domain only. Okay. So this is college algebra. We're finding the domain. Okay. All right. So it's like when you try to do these, unless there's something weird and funky going up here, you're basically focusing your attention on the denominator and see what is going to make this equal 0. Okay, denominator, domain, they both begin with D. DD, there you go. I just said it, Deidre. I was like, I think you were typing while I was explaining it. Okay, like Precalculus, this is what you're doing right now. Yep. Well, you gotta remember, this is September, so there's a lot of classes, Precalculus, some part of calculus. You guys are doing a lot of this pre-stuff, which was formerly Algebra 1, Algebra 2 stuff. Well, this is basically like Algebra 2, I would say. All right. Well, thank you. All right. Okay. So let's give this one a try. Oops. And I appreciate the gifts. If we could also tap up for the live, I greatly appreciate it. Because we have 174 of us. If we can just think about how you got here on your FYP. Because someone that you knew tapped, and next thing you know, you're seeing some of their stuff. What are the things that they like? Maybe it was a random person out of a grow room. I don't know. I know, that's why I had to stop doing grow rooms. My goodness. Some people just... Oof. Okay. No problem. Yeah. So anything that's happening in the denominator, That's telling us, okay, we want to know when is that domain or that denominator going to equal 0, because that helps us with our domain. All right. So now, take a look at the domain. Okay. Thank you, Mars. Thank you. So if we take a look at the domain, my GCF is going to be 3. All right, I was here. Okay. It's not Common Core math. Thank you, Meat Rock. So when we got that, we're factoring out our 3. Okay, because 3, 9, and 6 all have multiples of 3 in common. So when I divide the original, just the denominator, we're not looking at the 6x. 6x is let me just cover it up. It is not even there, okay? So we're just dividing everything. So 3x squared divided by 3 gives me 1x squared, or I could just simply say x squared. Plus 9x divided by 3, that gives me plus 3x. And plus 6 divided by 3 gives me plus 2. Okay? We just factored out that denominator to look like this. So inside that parenthesis, I still see a square. That's telling me that there's a possibility that everything inside this parenthesis could be factored once again. So we don't have a GCF, but we might be able to factor this down with 2 factors. So this is what happens. My leading coefficient is 1. I can go ahead and split my x's. X here, x there. Okay. Yep, we can factor it again. There you go, Kevin. Thank you. So we have to think, what 2 numbers multiply together to give me 2 and add together to give me 3? Well, 2 times 1 gives me 2, and 2 plus 1 gives me 3. And they're all positive. Now, would you be wrong if you put the x plus 1 first and the x plus 2 next? No, you will not. Okay, it's multiplication. And multiplication has that rule of commutative. There we go, the commutative property. But don't forget about a trifinance friend. Bring that person down. Okay. So now this is completely factored. Okay, this is completely factored. Okay, so we want to set all of these equal to 0. So I don't really have to set the 3 equal to 0, because can 3 equal to 0? No. But then I have this x plus 2 equal to 0, and my x plus 1 equal to 0. So if I subtract the 2 on both sides, I get my x minus 2. And if I subtract the 1 on both sides, these will cancel out. I don't need the 0. And I got my 0 minus 1. That'll give me my negative 1. So these are the 2 numbers that will make my original denominator equal to 0. Now I know someone said here that we can use a quadratic formula. Of course we could. But here's my thing. There are some people that haven't gotten to quadratic formulas yet. So I have to start where they're at. Okay? We have multiple ways of getting our answer. And then plus they always ask me, but why is it that? So at least this way they can see the why. Okay? So with the 3, if I set the 3 equal to 0, can 3 equal 0? No. If so, don't tell anybody because the government's coming after you to get the money back. Okay? Because that's not going to give us a true statement at all. So that's why we just focus on those two. Okay? All right. Okay. So now, if we take a look at it, we just want the domain. Okay, so you're not like, oh yeah, I'm done. No, you're not done. So now we have to figure out, excuse me, what our limitation is. So that means I can deal with all the numbers that are lower than -2 to get a true statement, but not including -2. And I can do a number, I can do 1.5 or -1.5, and I'll be perfectly fine. But if I use -1, that's going to give me a 0. But I can definitely use numbers higher than 0, especially if I use 0 itself. That's going to give me an answer of 6. So how I would write this is I always start with my lowest number. So you would go with -infinity to -2. And none of this should be a bracket. None of it. Okay? Then we're going to set our union. Then we'll start at -2 to -1. Then we have our union. Then we go from -1 to positive infinity. That's how you will write your answer out in an interval notation. Okay. Questions so far? CA, I have no idea what that is. It's just like an orange blob on my part. Why is it infinity positive again? Because you're going on both sides. We're going to continue all the way to positive infinity. You start at negative infinity, your lower numbers, going all the way to positive infinity, your upper numbers. Because we're only doing domain. Domain denominator. DD. Double D's. Okay? That's what we're only doing. That's our main topic for right now. Finding domain. That's it. Okay? I don't teach calculus. Sorry, swallowed the pills. I hope you're not swallowing pills. Nope. So Aaron, it can't not be just negative infinity to positive infinity, because if I plug in 2, let me plug in -2. Slide over here. So we have 3. And then we have our 9 plus 6. And if we plug in a -2, okay, here we go solving. -2 squared, that's -2 times -2, that gives me a 4. A positive 4. So positive 4 times 3 plus 9 times -2, that gives me a -18. Bring down to plus 6. 3 times 4 gives me 12. 12 plus negative 18, or 12 minus 18, that will give me a negative 6. Negative 6 plus 6 will give me 0. We don't want a number that's going to make our denominator equal to 0. So if you say from negative infinity to positive infinity, that means you're saying, hey, you could plug in any number in here and it's going to be perfectly fine. And you'll be a bold-faced liar. Okay? So we don't want to be in that position. So that's why we solved to try to figure out what numbers will make it equal 0. So that's why we got the negative 2 and the negative 1. So that's why you have to put these pauses in between so to show which numbers are your domain. Okay. All right. Okay. It's funny how people stop in here and they're like, oh my God, math, I just can't. But you stopped. You took it upon yourself. I know it was my voice. It was the sexiness. I know it really does draw people in. It doesn't matter to male, female. It just draws people in. But you stopped. And then you comment. So what does that say about you? Come on, Cushy. Let's go. All right. Let's see if we can get one more at least under our belts. All right, so we have 1 over the square root of x plus 2. Okay. We'll just give it the f function again. Make it into a function. All right. To your math days? Yes. Do I do Calc 3? No. All right. Don't be scared. And you're not ready? Okay. So what are you doing to study, to prepare? Okay, who's helping you? First thing, we want to know what's going to make this denominator equal to a 0. So since it's a square root, let's really focus on the square root. What's going to make this square root equal to a 0? So we take the radicand, so that's what's underneath the square root, and we set that equal to 0. Okay, so when we solve it, we subtract 2. Okay, then we have our x equals negative 2. So that means if I take this negative 2 and I plug it and substitute in for x, negative 2 plus 2 will give me 0. And the square root of 0 is 0. Okay, that's what's going to give me an error. But now I need to know, are there numbers that's going to be larger than negative 2 also going to satisfy this radical or square root? Or is it going to be numbers less than negative 2? So let's say a number bigger than negative 2 is 0. If I plug 0 in for the x, I'm going to get 0 plus 2, which gives me 2. And the square root of 2 is going to give me a positive answer. So that seems to work. If I wanted to say plug in 7, 7 plus 2 will give me 9. The square root of 9 is 3. That's giving me a positive number, so that's working out fabulously. But if I go, say, negative 3, negative 3 plus 1, that gives me a negative 1. And the square root of a negative 1, that gives me a complex number. Those imaginary numbers, those i's. And we don't want i's. Okay? We want real numbers that we're going to substitute in for the x to make sure it doesn't equal 0. So the best way will be dealing with numbers that are larger. If I wanted to go 14, 14 plus 2, that gives me 16. The square root of 16 is 4. So that means I'm dealing with numbers including that negative 2. Oh, actually, not including the negative 2. So sorry. The reason why I'm not including the negative 2 is because that's going to make my denominator equal 0. And 1 divided by 0, that'll be undefined. And we do not want that. Okay? But we want numbers at negative 2 and up. Bigger than negative 2. So that means we're looking at negative 2 all the way. Oh, sorry, wrong color. We're going from negative 2 all the way to positive infinity. So we can't include the negative 2 because that will give me an error in the denominator. So I'm going to have parentheses for my interval notation for both. And beyond. There you go. Right? That's okay. We're humans. We're supposed to make adjustments. So it's not equal to negative 2. Yes, Eddie. Okay. No, we're not doing trig. How do you do this? Like people gave you problems? Nope. I pulled some problems that I have ahead of time and I go through them. Need some review? Well, I have a tutoring business. So if you need anything of that sort, you can contact me just with the System Plus. Okay, so I do tutoring. I also have courses, and I also sell my books. Okay. Have you went over piecewise functions weeks ago? Actually, months ago, actually. Okay. So by hitting your Service Plus, you'll get all my information. You'll be able to get this. Okay. All right. So if you go here, you type in this, do those 5 things, and you'll see all of our replays from February 2nd. Yeah, if you say just infinity before the negative 2, that will be wrong. Because infinity does not go below negative 2. That's negative infinity. Okay. All right. All right, let's try. Let's try one more. No, it's just greater than. So Eddie will just be greater than because you're not including negative 2. Because if you included negative 2 in the previous one, it will give you a square root of 0. And the square root of 0 will give you 0. And we can't have a 0 in the denominator. So that's why it's not including negative 2. If it wasn't a fraction, if it was just a square root, then you can include it. But since it was a fraction, Yeah, you got to respect the denominator. No problem, Eddie. To find the denominator, we don't need a calculus system for this. We're just finding the denominator. Okay. So for this, we're looking at the denominator. So we're looking at to see what is going to make our denominator equal to 0. So first we're going to subtract 4. Then we have negative x squared is equal to negative 4. There you go. Good. Negative 1, we're going to divide both sides because we want to get rid of that negative in front of the x squared. And negative 4 divided by negative 1 gives me a positive 4. So now I have to do the square root. Remember, if they're starting off with 2, the opposite of a square is a square root. So it gives us x is equal to what? Plus or minus 2. Okay, if we have a square, that means we need to give 2 solutions. If you just say positive 2, you're just giving 1 solution. You need to give 2. All right, so it has to be plus or minus. There you go, Zach, thank you. So that means if I plugged in a positive 2 squared gives me 4. 4 minus 4 gives me 0. The square root of 0 is 0. And that's what we don't want. If I plug in a negative 2 squared is a positive 4. Negative 2 times negative 2 gives me a positive 4. 4 minus 4 gives me 0. The square root of 0 is 0, and that's not what we want. But I can plug in any number. Okay, if I wanted to plug in a positive 3. So we have 3 squared, that gives me 9, okay? But if I got my 9, then I have 4 minus 9, that gives me a negative 5. And this is an even root. It's a square root. We can't have a negative underneath there. Well, let me try something that's like maybe even lower. Let me try 0. Okay, 0, would that work? Let's see. If I plug 0 in, it'll give me a square root of negative 4, or square root of 4, and square root of 4 is 2. Okay, that works. But 0 is in between negative 2 and 2. Let me go lower. Let me just say, I don't know, negative 4. So negative 4 squared is 16. 4 minus 16, that gives me a negative 12. Ugh. Negative 12 is not going to work. Right, and we can't divide by 0. You're correct. I know. All right. So there you go, Zach. There it is. 1 second, I have to do the puzzle piece thing. Okay. So that's correct. So my answer is going to be in between negative 2 and 2. So how I write this, it's not going to go all the way to negative infinity, because remember we picked a negative 4, and negative 4 is going to be on this side of the number line, and it gave me like a negative 12 underneath that square root, and we can't have a negative 12. That's an imaginary number. We tried the 0, and the 0 is in between negative 2 and 2, and that seemed to work because we got an answer of square root of 4, and square root of 4 gave us 2. Okay, even if we wanted to put like a 1, if I put a 1 in, So 1 squared is 1. 4 minus 1 is 3. Square root of 3, that's perfectly fine because that's positive. So it has to be between -2 and +2. So how I write that is -2, +2, and I'm putting parentheses around it because if I made them brackets, I'm saying, oh, it's okay to have a 0 in the denominator. And no, it's not. That's going to be your answer. Okay? So all we're doing is finding the domain. We're not switching. We're not doing completing the square. We're just trying to find the domain. And the domain deals with the denominator. D, double D's. Okay? Did we use the square root to cancel the square? Yes, we did. Right here. Yep. That's how we're able to get the x by itself. All right. Okay. So, if you like these and you wish you can have something that's probably more geared to what you're learning in class, and it's for college algebra only, not calculus, not pre-cal, college algebra only, and you're an adult returning back to school. If you think you would love to have your own college algebra sections, let me know. Please DM me. If you are an adult that you're just like, I wish I could know this, I really don't know basic math, DM me because I'm thinking about doing like a foundation math class. All others, because if any for those to happen, it has to be like a super fans live only. So if you're thinking about doing these things, and I do have like any of those live onlys, I'm going to have you go and try to be a super fan. And super fans is like $99 or $9. Woo! $9.99 a month. And you can cancel anytime. You could just pay for 1 month and then cancel it. That's perfectly fine. But to eliminate a lot of the people that don't want to learn, or to basically eliminate a lot of the trolls, I think that's what's going to happen. And then I'm going to have some few free ones that's going to be very general. So like very general type questions. Okay? But sometimes you might need those specific things. The parentheses means unbounded and the brackets mean bounded. Brackets mean you're including them. If you think of intervals or inequalities, the brackets is a closed circle and the parenthesis is an open circle. Okay, thank you, Kat. Appreciate it. Trust me, I know the struggle is real. Okay. Yep, Buster, plus or minus 2. It's 2 answers. One's positive, one's negative. How did I get rid of the 3x? You don't get rid of the 3x. For domain, you're only focusing on the denominator. You're not focusing on the numerator. Just the denominator. Okay? All right. Okay, everyone. So that is today's session. All packed up. I will see you guys tomorrow evening if you wish. I'm going to just do a generalization one and trying to get GED. Okay, so if you need assistance, you're trying to get your GED. But here's my thing. Are you serious about getting your GED, or are you just coming in? Because if so, I do have tutoring sessions available. And right now my tutoring sessions are starting to pile up, which is great. But at the same time, how's that going to help you? You can continue on You can take a look at all of my notes if you want to. You can go here, okay, if you need to see all the recordings. Give me a few to upload the ones that I did today. The 4 days a week. Okay. So if you need assistance and you're really close to getting it, tutoring might be your best bet. Okay. What are they talking about? Okay. All right. So, but if you just want to take a look at the recordings, you can do that. You can look at my Service Plus. If you just, and that's the TikTok, you'll see at the bottom, you'll see everything that I need. And you just go ahead and reach out to me, DM me, if you're serious about tutoring sessions, and if you're serious about possibly doing a sub-only lives to break down. Okay? Exactly. Thank you, Mr. L. And we all know TikTok is going to take 52% of it. They say 50. It's not. So 52 of it's going to go to TikTok. But if that's the only way that I can actually promote something without being violated, and I do mean that, violated, or without getting a violation, then if that's the way that I have to reach people, that's the way I have to reach people. But if you want more of one-to-one, contact me. Now, I know my one-to-one is worth every freaking penny. So contact me. Yep. So at the bottom of your screen, you should have, it's a news feature that they have for the live, and it's called Service Plus. Okay, that's where you're going to find all my information, because I updated that a couple days ago. Okay, good job, Big Influence. Yep. Always asking questions. We had passed her GED yesterday. I know she announced it yesterday, which is awesome. I don't know. It should just be an orange thing that says Service Plus. But if not, because I know as soon as I say this, it's going to be like, oh, violation. I don't know. So it's somewhere. It's somewhere in there. Just got to look. If not, you can just go to my profile and take a look, because I have everything in there. Okay. Sorry to be so vague, but that's the only thing I can do for here. Okay. But there's a part that says that. All right. Okay. So sorry. All right. So I will see you guys tomorrow afternoon or slight evening about 6:30. And we're going to be doing a little bit, probably like some SAT generalization. Or we're going to be looking at maybe some more ASVAB stuff. One of the two. But here's the thing. No, I'm not. I lied. I'm going to be looking at, HESIs. So, but a lot of those things are basically the same, especially with the algebra. You know, it's just mostly the questioning. So that's what I'm going to be doing on Mondays, the HESIs. Sorry. Okay. All right. Yep, it will be Ty. Anything that's algebra is going to be on there. Okay. Especially for you guys, it's, what's it called? Ratio and proportions are going to be huge. Knowing your conversions is going to be huge, especially for the doses calculation. And if you're not following, make sure you follow a blessed RN to help you with your to help you with your doses calculations. She's really good at that. Okay. Yeah, she is. Most definitely. Okay, and if anyone that's taking the ASVAB, make sure you get access to the ASVAB for Dummies. I hate the name of the book, but that book, I've been hearing the way that they formulate their questions on the actual ASVAB is very similar. And it doesn't matter if you get this year's like 2025s or if you get 2022s. It's the same interior stuff. It's just a different cover. Okay, so if it's cheaper for you to get like 2022, get that. Okay, it's basically the same stuff. Alrighty. All right, thank you so much, everyone. I will see you tomorrow evening. Have a great rest of your day. Bye now.